last conic that we have not talked about, which is hyperbola. And so hyperbola, again, is based on having two parabolas. It's following the same process as the ellipse. That's really not going to change. The only difference is you'll kind of notice it once you see the equation. So when we look at the equation and we get kind of that same information that I gave you for the ellipse, for the most part, not much is going to change. We're still going to have foci, and the foci equation is the same. However, we're not going to have a major axis and a minor axis. And so instead, what we have is something called the transverse axis and the conjugate axis. But notice it's the same formula, 2a and 2b. So we have that. And then notice when it's horizontal and vertical, I don't necessarily like this equation necessarily per se. You can use an alternate form, which I'll write in a moment. And to find your c value, by the way, notice it's a little different. It's now c squared equals a squared plus b squared. Where have you seen that before? That's Pythagorean theorem. So notice from this equation for the hyperbola, it looks a lot like the ellipse, except one small difference. What is it? There's a minus in between them. So therefore, that's kind of what's going to go on. So you can think of this as a couple ways. You can have it this way, which again, then you're going to be having your, notice that the a squared and the b squared, for the most part, they're going to stay consistent. That's why I don't like necessarily this format. So another way to write this is y minus k quantity squared over a squared minus x minus h quantity squared over b squared. Because the one thing I like about a hyperbola is the a squared and the b squared don't move compared to the ellipse. So that's kind of the one thing that I do. I don't like necessarily doing it this way because I find it more confusing. And so if you look at my answer key, you're going to see me doing it this way and not that way. So it's not one of my favorites for doing it that way. And so when you look at some of these too, by the way, it's going to be kind of a different process. So it's a little bit different than an ellipse, but there's still going to be, again, some of the similarities. Separate your terms. You know, take out a common factor, a GCF. Complete the square. So some of those things are still going to come back, just like what we did with the ellipse and the circle and so forth. All right. Okay, so here we have this is going to focus more on writing the equation. And to be honest with you, are you going to be assessed on writing the equation? No. So I'm not going to worry about that. I'm going to worry about these. So the other ones, do me a favor, cross them out. We don't need them. I mean, we can do it, but to be honest with you right now, you're not going to have, your homework isn't going to look like that. And so therefore, why waste our time doing that when we can just be doing the graphing, because that's what you're going to be assessed on. So can you graph a hyperbola? You know, if you're writing an equation, then it'd be worth going through. But again, we're not really going to be doing that. Okay, so we're skipping 1 and 2, going to 3 and 4. So we're going to graph a couple, and then of course we'll graph some on your sheet to kind of get you going with your hyperbolas. And then tomorrow we're going to have uber fun. We're going to all smush them all together. And so you have to figure out what shape you have and then follow the process. So that's why we're going to take a couple days to kind of do that and cement it. Okay. So for this one, notice that the x squared is over here. And so that's going to tell me something about my hyperbola. So when the x term is over here, that's telling me that my hyperbola is going to look like what we call this. Okay. And so that's one of the beginning ideas that we're going to have. So let's kind of do what the first thing. This is in happy format. We don't really need to do the complete the square and separate the terms and all that other fun stuff. So what would be the center of this hyperbola? Right, so we're going to have, be careful. Wait a minute. I know some of you are saying -3, 0. But wait a minute. The x is over here. Oh, yeah. So I'm glad you guys kind of did that because that's a very common mistake. And so just be careful. When the x is over here, your h is still over here. So your vertex is actually, or center should be 0, -3. So that was a good discussion point, you know, to talk about that. So we have 0, -3 for the center, so I'm going to put that in. Okay, then what the next thing I like to do is find my A and B values. Okay, so because a hyperbola can be trusted with the A and B value, this is the A value always, A squared. This is always the B squared value all the time. So it doesn't switch around like an ellipse does. So therefore, we're going to go with this being A. So this is A squared. So A squared is equal to 4. B squared is equal to 9. So A is 2. B is 3. Everybody okay so far? Okay, from this A value, this gives me what we call the transverse axis. So the transverse axis is going to be just like what we did with the ellipse. Double it. So what is it? 4. The second one's called the conjugate axis. And the same thing, double the B. 6. Okay. So those are my transverse and conjugate axes. All right. Now here's kind of my favorite part. Now we put in the A's and the B's. So because, be careful though, the A is under what letter? The Y. So that's telling me this is the direction we're going this way. So from the Y, I'm going to be using that A value. So I'm going to go up 2 and down 2. So put 2 dots there. And then under the X was the B value of 3. So I'm going to go from the center, left 3, and right 3. Everybody okay so far? Kind of looks like the beginning's sort of like if what an ellipse would kind of look like. But the hyperbola, this is where it starts to change. So what you do now is now we're going to make a box, all right? And in such a way connecting all the points. So it's going to make a rectangle. So what you end up doing is you connect it so that these 4 points make a box. So, yep, hyperbolas, you got to box it up. Okay, since there's parabolas, we have something with this, with the hyperbola, we have something called asymptotes. Remember asymptotes? So, you could actually find the equation of the asymptotes, but I'm going to teach you a shortcut. The shortcut is to draw the diagonals in the rectangle. So if I'm here, my diagonal is going to go this way, and it's got to go through your center. So one of my diagonals is going to be there, and then one of my diagonals is going to be here. Okay, and then the last step that we can do is we can graph it. Now remember how I said it's going up and down? So this is the point I'm going to use. So this is going to go up like that with like a parabola. The asymptotes are trying to show you how far spread to make your parabola. So that's the purpose of the asymptotes. And then this one's going to go down here like this. And there it is. Want to go through foci? No. Don't hurt my feelings. Foci are fun. Foci is actually kind of fun because this time you're doing the Pythagorean theorem. So you're just going to have 4 plus 9. So what's 4 plus 9? 13. C squared is equal to 13. So C is equal to what? The square root of 13. And then the foci equation says for when the hyperbola goes like this and down like this, the h value will stay the same, which is 0. Your k will stay -3. One of them you're going to add the square root of 13, and the other one you're going to subtract the square root of 13. Foci are really not that bad. But it's up to you. Again, I'm not making you do foci. But you can't say next year to your pre-calc teacher, don't know anything about foci. Come on. All right. Most of our equations are going to look like number 4. Aren't they fabulous? Don't you love number 4? No. Well, we've got to make it look pretty so it looks like number 3. So that's our job. So we got to first make it look pretty so it looks like number 3, and then we go do that process. Okay? So think about what we were doing with all our other ellipse conics. What should we do first? So remember, if you want your step-by-step process, remember we're going to separate your terms. So x's go with x's, and y's go with y's. So we're going to run out of room to write, but oh well. So we're going to have x squared minus 2x, and then minus 16y squared minus 32y. And then what are we going to do with the negative 31? Put it on the other side, so it's going to become positive 31. So that's step number 1. Has that step changed from any conic we've done so far? No. So I'm going to beat this algorithm to you to death because you're following the same thing. Notice I put a fun computer science term in there. Algorithm. Okay, what's next? Well, one of them I can complete the square right away, but one of them I can't. So remember, usually your second step is to factor out a GCF. Yeah, I need it. And so for the y's, it is needed. So the x squared is fine. What should I factor out for the y squareds? The y. So what should go away? Negative 16. Well, actually, leave the negative. Let's just take out, we'll take out 16. What? All right, fine. We'll divide out negative 16. I know, I'm teasing you. Yes, you can take out negative 16. Okay. So negative 16 y squared divided by negative 16 would be y squared. You want this minus here anyway, because in a hyperbola, it's supposed to be a minus. It's not an ellipse. Okay. Then, now be careful here. This is where students always make mistakes. Negative 32 divided by negative 16. Yes, so this sign switches. So be super duper careful, because does that matter? Oh yeah. Oh yeah. So that's 31, even though that's what we were looking for, 31. That's better. And then, of course, your third step is to, again, complete the square. What's the matter? Nope. I'm taking negative 16 out of both. We're good. Because this is just going to count as a plus negative 16 anyway, so it's not a minus minus thing, so it's not going to switch sign. All right, so next, complete the square. So cut the negative 2 in half and square. So that'll be 1. And then we're going to complete the square on the other one, which is going to be the same thing. It's still going to be 1, but we have an issue. So with this 31, what are we going to do? So we completed the square, so we have to do some magic. Because otherwise this equation is not true. So I should add 1 to this side from here. What do I need to go from here? Yeah, I need to subtract 16 because this is really negative 16 times 1. So I'm really subtracting 16 from that side. So therefore, I'm going to need to do that to the other side. And then we get to do my favorite part, which is to factor. So you're going to factor your trinomials. And then this will get us in pretty much the happy mode almost. So we'll have x minus 1 quantity squared minus 16 parentheses y plus 1 squared. And then we're going to put all these together. And so we're going to get 16. Everybody okay so far? So not much different than the ellipse. Now, think about the ellipse. What is this supposed to equal? 1. So does a hyperbola. It's got to equal 1. So what am I going to divide by? 16. Okay. And so when we divide by 16, we're just going to have x minus 1 quantity squared over 16. The 16s will cancel. But that will just be over 1 because 16 divided by 16. So I'm just changing the bottom to be a 1 because there needs to be a number down there. And then 16 divided by 16, of course, is 1. So now we did all that fun math work, and now our equation is beautiful as number 3. So now we just have to finish the part where we need to graph it. So what's the center? Yep, so 1, negative 1. And then we're going to start thinking, okay, what is A? What is B? Remember, this a squared and b squared don't switch. And I forgot to mention, because the x is in front, this is going to go this way. Okay, so your hyperbola is going to go the traditional way, which is that thing. Okay, so therefore, what number is going to be a if a squared is 16? 4. Okay, if b squared is 1, what is b? 1. Okay, now let's find our conjugate axes and our transversal axes. So how long will be the transverse axis? 8, because 4 plus 4. So that's 8. Okay, how long will be my conjugate axis? 2, because 1 plus 1. All right, now we're ready to graph. Now notice though the 4, the a value is under the x. So that tells me from once I put my center point in, we're going to go, again, left and right 4. And the b value is under the y, so that tells me I'm going to go up 1 and down 1. So now I'm going to go back to my grid, if it lets me go back down to my grid. Okay, so we had what? 1, -1? And then let's see what we had. What do we have for? I don't even remember because I can't see my writing. Okay, didn't we go left and right 4? 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. And then we're going to be going up 1 and down 1. And then what do we do next? Box. So then after that, we make the box. And then after the box, we do what? Drawing your diagonals. Yep. Remember, your diagonals have to go through the center. And then, remember I said that the hyperbola goes this way. So that means I use this dot. And again, the reason, again, I have my asymptotes is to kind of show me how much that those parabolas are curved. Okay, if I wanted to do foci, so this is kind of a star point. If I wanted foci, I'd have c squared is equal to a squared. Let's see, what was a squared again? 16? Remind me. Yes. Thank you. And then the other one was 1, right? So then we're going to have 17. So c is going to be the square root of 17. So with my foci, because it's a traditional one, the k value is going to stay the same. And then this one's going to be 1, and then this will be 1 plus the square root of 17, and this one will be 1 minus the square root of 17. So that would be the foci. Pretty intense, huh? That's the hardest conic that there is. So, but it's just kind of a step off from the ellipse. So that's it for hyperbolas.